It's Flashcard Fridays at Math Science History. I'm Gabrielle Birchak, and today we're going to take a quick trip into the suitcase. Literally. But first, a word from our advertisers. Have you ever found yourself sitting on your luggage, desperately trying to zip it shut? Or playing Tetris with your shoes, socks, t-shirts, and pants? Believe it or not, this problem has fascinated mathematicians and computer scientists. It really has, especially when you're a fashionista, a nerdy fashionista like me. It's called a packing problem, and it's all about optimization. Let's take a closer look at how this mathematical idea helps you get the most out of your luggage and how it applies far beyond travel. Like if you have a purse. Which I do, and I often lose things. So this podcast is going to serve me well. So what are packing problems? Packing problems fall into a category of mathematics called combinatorial optimization. The basic idea is this. How do you fit a set of items with different shapes and sizes into a limited space as efficiently as possible? There are two-dimensional packing problems, like arranging photos in a collage, 3D packing problems like your suitcase or a shipping container, and even multi-dimensional ones that exist in data science. One of the most famous in data science is the bin packing problem. Imagine you're trying to pack items into as few bins as possible without exceeding the bin's weight or volume limit. This exact scenario is used in logistics, airline cargo loading, and even cloud storage algorithms. But why is it so hard? Okay, here's the twist. Packing problems are what we call NP hard in computer science. That means there's no known fast algorithm that always gives the best solution, especially when the number of items grow. In real life, when you're packing your suitcase, you're solving a simplified version of a three-dimensional bin packing problem. But unlike a machine, you're using instinct, muscle memory, and visual estimation. That's why a perfectly packed suitcase feels so satisfying. It's a little victory in an unsolvable world. That is until you get to the airport and you have to pay for your luggage. That's another story for another time. So here are some tips from the math world. How do the pros or the algorithms do it? Well, first, they sort by size. Always pack the largest and bulkiest items first. This is a classic strategy in optimization. Get the hardest pieces out of the way. 2, fill the gaps. After the big items are in, use smaller things to fill the awkward spaces like socks inside shoes. This is called greedy filling. 3, rotate for fit. Just like rotating puzzle pieces or rotating those Tetris pieces on the game Tetris, rotating items can make a huge difference. In mathematical terms, this is considering an item's degrees of freedom. 4, roll, don't fold. Rolling clothes makes them more compact and stackable, kind of like using soft, pliable pieces in a game of spatial optimization. So some packing apps and shipping software actually use algorithms inspired by this math, like heuristic solvers or genetic algorithms to get close to the best possible solution in a short amount of time. So here are your takeaways for this week, especially if you're going on vacation. Packing your suitcase is a real-world math problem. It's an NP hard one. That's right. Optimization techniques like sorting, rotating, and greedy filling are key strategies, and packing problems show up in shipping, logistics, cloud storage, and even warehouse robots. So the next time you zip up your luggage, give yourself a high five. You just solved a math problem that stumps computers. You are a mathematician. Thank you for joining me today on Flashcard Fridays. And if you liked this bite-sized brain boost, don't forget to subscribe and leave a review. You can find show notes and more fun facts at mathsciencehistory.com. And until next time, pack smart, stay curious, and carpe diem.